So we got the infamous Captain Crunch wing here. I'm making a second copy so you can kind of see different stages of the process. Here's the finished one. Rides great. And now this one in progress, you can see I epoxied it together here. And we're going to sand that down, file it, sand it, and then paint it up, smooth it out. And this guy, we just bonded in our 6mm inner tube, and that guy goes all the way out through the screw holes, and our 16mm main tube that goes about halfway down. And this also has ribs 3D printed inside, so this thing is, she's solid. I'll say that. So next we'll cut the tubes off, drill straight through the tubes with a carbide bit, and then melt in a couple threaded inserts there. And then on this side, we just melt in M4 threaded inserts. So that's kind of the general construction. Now, talking about the wing itself, this idea was inspired by the goal to make a heavy, full weight efoil feel light and responsive. And normally going to a smaller tail wing will, liven up the ride, presuming you're on a smaller wing, like under a 150 or a high aspect, especially very, very fast roll. I typically ride the 92 Havoc. It's like an 8.5 aspect ratio, 590 square centimeter. So going to smaller by 18 square inch, like 130 centimeters squared, around there, 140. It was very fun, except the drag of the motor, it was too high basically to ride off power with the folding prop. So I needed more pitch stability and more pitch force from the stabilizer. So I made this kind of mid-length. It's 175mm from the front of the wing to the back of the fuselage here. It's kind of in between the lift, carve, and glide series, like right in the middle. And then when it came to the wing, I was thinking to myself, I want all the power concentrated in the middle to maintain a very fast roll. It's just like a very narrow section that's creating that force, and it'll make it less stable, so more maneuverable. And then I wanted to keep the aspect ratio high to keep the efficiency up and give a nice loose feeling and minimize the tip vortexes here, which actually creates stability. So minimizing the tip vortex also maintains an extra level of maneuverability. And pretty much I was like, how crazy can I go? I previously tested some twisted wings where it was just a straight wing with a twist. Got one right here for you. So this one was sort of the precursor. I don't know if you can see, but the tip is sort of flat and the middle is just cranked. And this was the predecessor to the Captain Crunch. Felt really fun, super loose, on power. When you have the motor providing additional stability, it was fantastic, but it just didn't quite have enough stabilizer force to run off power on wakes. Maybe with the 55 motor on the lift foils or with a prone foil, it'd be great, but the 68 full-size motor, it just has too much drag. And particularly when you're also going at high speed, the downward pitching moment of a highly cambered wing, like a high aspect wing, or even just a larger wing, as you speed up, it starts to want to pitch down. And this stabilizer did not have enough counterbalance to that. So it got a little bit unstable at high speed. So basically we took this idea and said, okay, how do I add more area, but keep the aspect ratio, add more area, and concentrate it, that lifting force in the center of the wing. So I said, screw it. We just screw the cord out to 80mm in the center, and we used a thinner profile. So on this wing, I had to use a 20% profile to get the carbon tube in there, but with this additional cord, now we can run a 12%. So that's why it's a 4412, so NACA 4420. And it allowed me to use a 5 and 2.4mm carbon rods inside. So once I kind of figured that out, I said, okay, well, let's adjust the area and the shape until we get about the right amount of surface area. So I sort of settled on 28 square inches. It's a 34 centimeter span, and we got a 15 millimeter tip cord. I adjusted like a midsection here is a 16% thickness profile, and that was kind of how I modulated the fat section. And then I created some intersection curves to loft the airfoil sections together and make the final shape. So it does look a little bit funny when you look at kind of this transition here between the main sort of large cord section and the thin section. It looks funny, but one of the challenges I had to make sure was when I was doing my section analysis through the wing, I noticed that the spline curve I used was wrong, and the wing actually changed angle halfway through. So when I used an intersection curve, projected top and from behind, I was able to make sure that the trailing edge was always higher than the leading edge. So as you cut the section in the computer, you can see that the wing always has a positive angle of attack all the way through. So that was a critical design element to make sure it would work well. And then in general, one of the other cool tricks I learned from the small wing, this has 10 degrees of twist. So when your tips are at 0 degrees angle of attack, your root is at 10 degrees. And that worked great. So we kept that same philosophy here. And not only is the area more here, but the angle is steeper. So those two create a significant amount of concentrated lifting force just in the center. And then it washes out pretty significantly as soon as you drop here off of this, I don't know what you call it, transition. And the nice thing about it is that we have a very gentle curve here and a long, it's essentially a wingtip. It's not doing a whole lot of lifting, but it's preventing the flow from creating the vortex. So you could think of like a horizontal winglet instead of vertical, it's horizontal. That's essentially what it's doing. But having a nice wide, large radius curve here prevents a vortex from really forming off of this transition, which would, increase drag quite a lot and negate some of what I'm trying to do. Now, I'm sure there is a bit of swirling, but the name of the game with the vortex is to spread it out and not create like a tight spiral. So by having, this super high pressure difference here and then fading it off, we're allowing that pressure difference to gradually decrease until it's almost 0 at the tip. We might be running this actually at a slightly negative angle of attack. I have it set at 8.5. So yeah, this is at -1.5 on the tips. So just a very, very small amount of lift being created, and that contributes to a pretty good efficiency, even though we have a super high angle of attack at the root and a large area. We can maintain nice efficient flight and efficient force creation. So let's say pounds of lift per unit of drag, right? Your lift to drag. And in terms of ride characteristic, this thing really surprised me. It had the same feeling of the skinny one. Again, just like loose is crazy loose, but like in a fun way. It was predictable. You bank it into a turn, and it just took such a little amount of effort to flip it over. It wasn't like gonna throw you off, like it was wobbly. It was like you just push with your toes a little bit and the board will move. So you just steer with your eyes and it feels like it's reading your mind. And even though something like a 26 carve, which I got somewhere over here, it's a very maneuverable wing, but it still has, like, I noticed after switching from this starting to the 26 carve, I tried to make a sharp turn and I could feel it like delaying. I had to put more effort into the board to make it roll, and then to flip the transition over. So maybe I'm banking heel side this way, and then I want to roll it over. The 26 carb, I needed to give it more effort to get the board to flip attitude and bank into the other turn. So I think that's where the characteristic of this excels. It's got a lot of stabilizer force. So when you're turning, it's stable and you can have good pitch stability in a turn. But when you want to transition, it takes a very little amount of effort to roll the board over center and get the direction changed to the other turn. And the other nice thing is that it has no winglets on it, so the yaw is nice and loose also. That's a characteristic I like about high aspect wings. I noticed they're much more loose in yaw, and that's really fun. So in general, what it really reminded me of was I got a chance to ride a flightboard with the Flightboard Ultra with a Flow S900, and that has wingtips that go up, which creates super loose roll control. And that board was set up with like a 290 stabilizer. So again, very pitch stable, but with that, with dihedral wing in the front, it was incredibly roll loose and just a kind of a different setup than your typical lift foil, which is more pitch loose and roll stable. So when I had this paired with the 150 high aspect X, it felt much more like the Flightboard. It had pitch stability, but just crazy roll maneuverability. And I think I'm narrowing in on my theory that the lift and the flight are set up different, and that's why people feel like they ride so much differently. But you start taking a Flightboard and you put a 160 like from the Flight Lab or 130, a small stabilizer, you'll start to get the same feeling as the lift foil. And with the lift foil, if you put a larger stabilizer and a looser front wing, you will get back more of that feeling of the Flightboard. So kind of an interesting experiment I got going on. Now that I've got two of them, I can send one out to have somebody test it. So if you're watching this all the way at this point, I think you've earned an opportunity to give it a try. So first one to email me gets it pretty much. Everybody I emailed didn't want it yet. So shocking, I know. It's crazy. But this thing is so fun. And yeah, hopefully I'll be able to take it out again next weekend. We'll try out the second fuselage and do like more back-to-back testing on the 92 Havoc and the 150. Just switch between like the 26 carve and then like a larger stabilizer like a 32, or even I have a 46 glide I might try. And basically just make sure I'm not crazy. And that it is as fun as I felt it was the last couple times out. So anyway, I hope you learned something interesting about the stabilizer design, and maybe I inspired you to try something on your own. Like I said, these CAD models are available for you to 3D print and download, and they stack together with a little epoxy and carbon tube I got on eBay. So they are very doable to make, and you can construct them for your lift foil. Or, I mean, you could reconfigure it for a Flightboard or any other prone foil as well. So I encourage you to give that a test drive. And yeah, let me know what you guys think about it. But thanks for watching, and I will catch you guys in the next one. Cheers.